in this question, we can look at it, solving it from exponential growth, like exponential function, or we can look at from geometric sequence. And I just want to explain how to approach that in two different ways. So here we have the population of region is now 6.7 million people. This population is growing at a rate of 10% per year. At this growth rate, the population will be greater than 20 million for the first time in some number of years from now. And therefore, we have to find that value of n. So basically, when are we going to have 20 million? So if you are thinking about that, our starting point, 6.7 million, that's the starting point. And then 1 year goes, and then what happened? We have 10% more. So now we have 6.7 million people and 10%. So 110%. And then again goes another second year. And then we have what we had before, so 6.7. And then that number is again multiplied by 110. And so on. And we can keep on going. So that's how it works. Therefore, I'm thinking the more years, the more time, I'm going to be multiplying by 1.1 to 110%. So I'm saying the way it will work is 6.7 multiply by 1.1. Let's change that to a decimal. If it was here 1, we're going to put 1. If it is 2 years, we're going to have 2 of 1.1. If it was 3, 3, and 5, we'll have 5, and so on. So here we are saying n. So we are saying at what point this calculation will give me 20 million. Let's equal to 20 million. It's easier to solve that with equal sign than inequality. So how do we solve it? N is what? Power, isn't it? That's our base, 1.1. Now, in order for my base, power, and product, isn't it? To apply that idea that when I'm looking for the power, I'm using the log, saying I'm looking for the power of whatever base of whatever product, that calculation will give me power. I need to have base and power on its own, so 6.7 has to go. Therefore, I divide both sides by 6.7. And now I have clearly the product, 20 divided by 6.7, the base 1.1, and n being the power. Therefore, log of the base 1.1 of the product 20 over 6.7 will give me n the power. When we put that in the calculator, we're going to get 11.47. Now, we know n belongs, we are told, belongs to n, meaning it's a whole number. So at 11 years, we're going to be less than 20 million. So during the 12th year, once 11 years is finished, during the 12th year, we're going to hit a point where we're going to have exactly 20. So that 12 years is the one that will have greater than 20 million. So we can look at it from this point. But somebody can say that reading that question can say, that sounds like geometric sequence, isn't it? Because every time we are multiplying by the same value. So we are saying we are looking for the term, isn't it? Because the term is the number of people. So we are saying, how is that going to work here? We understand that Tn, the value of the term is going to be 20. We understand that the first number, value of the first term is 6.7. We understand that every time I'm multiplying by 1.1, then I'm saying, okay, I'm looking for n. Now, if we do this calculation, okay, let's replace. And I suppose it will be easier for me to explain on a specific number. So again, the same idea, we divide by 6.7 both sides because we need that power base product. So 20 over 6.7 equal 1.1 and minus 1. So we are saying therefore log of the base 1.1 of the product 20 over 6.7 give me the power and minus 1. Since I want n, I move that one minus 1 to the other side, change the sign. And then we have n on its own. We put that in the calculator. Now here, we're going to get 13. Oh, I'm sorry, not 13. 12. We're going to get, oh, sorry, something wasn't working for me. 12.47 over n. So how come here it doesn't become 13? So let me just explain here that our term 1 was what? 6.7. Don't forget that in this particular question, n represent number of years. Though here n is 1, but how many years does that n stands for? 0 years, isn't it? Because that's no years have passed. Then term 2 will be that 6.7 multiplied by 1.1. So that is my first year that is gone. Yeah. Term 3, then it will be my second year, multiply again by 1.1. So that will be only second year, but term 3. Therefore, here it is term 13, but term 13 means 12 years. Yeah, so that's the only difficulty here with approaching it as sequence and series. But I wanted to show you because some of you may be thinking, oh yeah, that could work here. That looks like that, isn't it? But that's the only thing we have to be aware, that actually this n from the formula is not the same like this n, this n that they are looking for in here.